Assalamu alaikum wa rahmatullahi wa barakatuh. Today, I'm going to talk about the relations. In this lesson, we got to know the concept of the relations and how to represent it by using the arrow diagram and the Cartesian diagram. But before I start, we need to remember what we have studied before. In the previous lesson, we studied the Cartesian product of two non-empty finite sets. It is the set of all ordered pairs whose first projection belongs to the first set and second projection belongs to the second set. And then we studied that the two coordinates x-axis and y-axis can divide the graph into four parts. And the first part is called first quadrant. And any ordered pair inside it, its first projection positive and second projection positive. And then the second part is called second quadrant, and any ordered pair inside it, its first projection negative and second projection positive. And the third part is called third quadrant. Its first projection negative and second projection also negative. And the fourth quadrant is called, the fourth part is called fourth quadrant, and its first projection is positive and second projection is negative. Example, if the point x and 2 lies on y-axis, we said before that if the point lies on y-axis, that means the first projection must be 0. So here, the first projection is x, and x must be 0. B, the point -1 and 3 lies in which quadrant? As we said before, if the first coordinate is negative and the second coordinate is positive, that means the point lies in which quadrant? It lies in the second quadrant. C, if the point 7 and x minus 5 lies on x-axis, we studied before that if the point lies on x-axis, that means the second projection must be 0. Here, if we replace x by the number 5, the result is going to be 0 because 5 minus 5 equals 0. That means x must be 5. And now we will take the relation. What is the meaning of the relation? Suppose we have a group, X contains the names of the students, Ali, Ahmed, Mazin, Omar. And another group contains sports, football, handball, tennis, and basketball. And suppose that Ali likes playing handball and Ahmed likes playing football. And also Ahmed likes playing basketball, but Mazin doesn't like playing any sport. And Omar likes playing tennis. Here we can find the relation between the two groups. The first group contains Ali, Ahmed, Mazin, and Omar. And the second group contains football, handball, tennis, basketball. The two groups are connected with a relation. Ali likes handball, and the first ordered pair must be Ali and handball. And Ahmed likes football, and the second ordered pair is Ahmed and football. And then Ahmed also likes basketball. So the third ordered pair, Ahmed and basketball. And the fourth ordered pair, Omar and tennis. And the fourth ordered pair must be Omar and tennis. And this is called the set of the relation. So from here, we can deduce that the relation is a connection between two sets. It connects some or all elements of the first set with some or all elements in the second set under condition. Remarks. If the ordered pair A and B belongs to the set of the relation, that means A or B. It can be written A or B. What is the meaning of A or B? It means the ordered pair A and B belongs to the set of the relation. There is a relation between A and B. And also we need to know that the set of the relation is subset of the Cartesian product of the two sets. Suppose we have a relation between x and y. That means this relation subset of the Cartesian product of x by y. Number three, the relation R from x to y can be represented by an arrow and Cartesian diagram. Example, suppose we have two non-empty finite sets. The first set denoted by letter x and contains 2 and 3 and 5, and the second set y contains 1 and 4 and 7. And R is a relation from x to y, where A or B means A less than B. For every A belongs to the first set x and B belongs to the second set y. We need to state the relation and represent it by using the arrow diagram and the Cartesian diagram. At the first, we need to draw an column. A column contains the elements of the first set, 2 and 3 and 5, and then draw the second column, which contains the elements of the second set, 1, 4, 7. Look at the condition here. A less than B means the first projection must be less than the second projection. The first element in the first set is 2, and we know that 2 less than 4, so we need to draw an arrow from 2 and to 4. And also 2 less than 7, draw an arrow from 2 to 7. And 3 less than 4, draw an arrow from 3 to 4. And also 3 less than 7, draw an arrow from 3 to 7. And 5 less than 7, draw an arrow from 5 to 7. And this is the arrow diagram. What about the Cartesian diagram? As we studied in the previous lesson, we can draw the first column or the horizontal column, which contains the elements of the first set, and the second column or the vertical column, which contains the elements of the second set. And then plot each ordered pair. The first ordered pair, 2, 2 and 4. So this point is located here. Its first projection 2 and second projection 4. And the second order pair 2 and 7, and it is located here. Its first projection 2 and second projection 7. And the third order pair 3 and 4. Its location is here, and the next order pair 3 and 7, its location up here, its first projection 3 and second projection 7. And the next ordered pair 5 and 7, its location up here, its first projection 5 and second projection 7. And this is the Cartesian diagram. Now we can write the set of the relation. It contains the ordered pairs 2 and 4, 2 and 7, 3 and 4, 3 and 7, and then 5 and 7. 2 and 4, 2 and 7, 3 and 4, 3 and 7, and then 5 and 7. This is the set of the relation. Another example. Here we can find the relation of x to y. Here we have two non-empty finite sets. X contains 2 and 3 and 4, and y contains 4 and 5 and 6 and 7 and 8. And R is a relation from x to y where A or B means A plus 3 equals B. For every A belongs to x and B belongs to y. We need to state the relation and represent it by using the arrow diagram and then the Cartesian diagram. As we said before, we need to draw a column which contains the elements of the first set, 2 and 3 and 4. And the second column, which contains the elements of the second set y, and contains 4 and 5 and 6 and 7 and 8. According to the condition a plus 3 equals 7, that means the elements in the first projection, if I add 3 to it, the result is going to be equivalent to the second projection B. Here, the first element in the first set is 2. If I add 3 to 2, the result is going to be 5. So we need to draw an arrow from 2 to 5. And if I add 3 to 3, the result is going to be 6. So we need to draw an arrow from 3 to 6. And if I add 3 to 4, the result is going to be 7. So we need to draw an arrow from 4 to 7. And now we can easily, and this is the arrow diagram, and now we can easily represent this relation by using the Cartesian diagram. Draw the first column or the horizontal column, which contains the elements of the set X, 2 and 3 and 4, and the second column, which contains the elements of the second set Y, 4, 5, 6, 7, and 8. And the first ordered pair is located here. It's first projection 2 and second projection 5. 2, let's 2, if I add 2 to, if I add 3 to 2, the result is going to be 5. So the location of this point is here. And then 2, and then 3 to 6. 3, if I add 3 to 3, the result is going to be 6. So its location is up here. And the third ordered pair, or the last ordered pair, is 4 to 7, because if I add 3 to 4, the result is going to be 7. And its location is up here. And this is the Cartesian diagram. Now we can deduce the set of the relation. It is the set of ordered pairs 2 and 5, 2 and 5, and 3 and 6, 4 and 7, 2 and 5, 3 and 6, 4 and 7. This is the set of the relation. Another example. Here we have n non-empty finite sets X contains -2, -1, 0, 1, and 2. And R is a relation on X, where A or B means A is the additive inverse of B. For every A and B belongs to the same set X. We need to state the relation and represent it by using the arrow diagram and the Cartesian diagram. At first, we need to draw the arrow diagram. We need to draw a rectangle or square contains the elements of the set X. -2, -1, 0, and 1, and 2. This is the elements of the set X. According to the condition, A is the additive inverse of B. The first projection must be the additive inverse of the second projection. And we know that the -2 is the additive inverse of 2. So we need to draw an arrow from -2 to 2. And also -1 is the additive inverse of 1. So we need to draw an arrow from -1 to 1. And we know that 0 is the additive inverse of itself. 0, its additive inverse is also 0. So we can draw a loop. This is called a loop outside the 0. And also we know that -1 is the additive inverse of 1, and also 1 is the additive inverse of -1, and 2 is the additive inverse of -2. And this is the arrow diagram. Now we can represent it by using the Cartesian diagram. This is the first set, and this is the second set, or the same set. And the first ordered pair, -2 and 2. And then -1 and 1. 0 is the additive inverse of 0. And 1 is the additive inverse of -1. 2 is the additive inverse of -2. And this is the Cartesian diagram. Now we can write the set of the relation. It is the set of ordered pairs, -2 and 2. -2 is the additive inverse of 2. -1 and 1, 0 and 0, because 0, its additive inverse is also 0. And 1, and -1, 2, and -2. And this is the set of the relation. Here, if X contains 2, 4, and 6, and R is a relation on X, where A or B means A is the divisible by, this is wrong, A is divisible. We can cancel that. A is divisible by B, or the first projection is divisible by the second projection. For every A and B belongs to the same set X, we need to state R, or the relation, and represent it by using the arrow diagram and the Cartesian diagram. And first, we need to draw a square or rectangle contains the elements of the set X, 2, 4, 6, 2, 4, 6. This is the elements of the first set. According to the condition, A is divisible by B. The first projection must be divisible by B, or in table B. 2 is divisible by itself. So we need to draw a loop outside 2. And also 4 is divisible by 2. We need to draw an arrow from 4 to 2, because 4 is divisible by 2. 4 is in table 2. And also 4 is divisible by itself. We can make a loop outside 4. And 6 is divisible by 2. We can draw an arrow from 6 to 2. And 6 is divisible by itself. We make a loop outside 6. And this is the arrow diagram. What about the Cartesian diagram? We draw the first column, which contains the elements of the set X, 2, 4, 6, and the second column, which contains the elements of the set X, 2, 4, 6. 2 is divisible by 2, and 4 is divisible by 2. 4 is divisible by 4, and 6 is divisible by 2. And 6 is divisible by itself. 6 is divisible by 6. And this is the Cartesian diagram. Now we can easily write the set of the relation. The first ordered pair, 2 and 2, because 2 is divisible by 2. And the second ordered pair, 4 and 2, because 4 is divisible by 2. And 4 and 4, 4 is divisible by 4. And 6 and 2, 6 is divisible by 2. And 6 is divisible by itself. And this is the set of the relation. Now we have finished the lesson. And in the next lesson, we will study the function. Please study hard. And thanks.